Hello and welcome to Grade 10s. This is your favorite show, the Learning Show, which is Learn Extra Live with me, AB, and Natasha. How are you, Natasha?
I'm very well, thank you. Good to see you again.
Yes, welcome to this fourth term and the last term. How are you feeling?
I know, I can't believe how the year has just flown by.
Sure.
It's absolutely incredible, and literally exams around the corner.
Tell me
Crazy.
about it. And guess what? There isn't a lot of topics, new topics that needs to be covered, I believe. There's just revision going on.
Well, I think that's the key. Everyone should be revising by this stage in the year, so obviously that's what we're doing.
Right. Well, Grade 10s, as we're talking about revision, Mindset has partnered with Samsung Learning Hub to give you that revision, to help you through by simply downloading the information and the notes that we have on the Samsung Learning Hub. So I'm going to be taking you through to some steps with Natasha, of course, on how to access it. One, you need to be using a Samsung tablet or a Samsung premium smartphone. So that's how simple it is, Natasha. We need to buy ourselves, hey? I already have mine.
I need a tablet, Samsung, if you're listening.
Okay, and then I go for a premium smartphone. But then for somebody that is like Natasha, you can go to their Learning Hub. That's how you'll access it. But if you are like me, want to be using the premium smartphone, you go to Samsung Hub and then select Learning. Then after that, you'll browse and view the content that we have. Then should you want to download, the only way it is to purchase the material, and you'll be asked to put in your email address, and that's how you register. After that, it's going to launch the hub. That's where you'll be able to access the content, and then you'll see this notice that is on your screen. Wow, welcome to the Samsung Learning Hub. And then you get a free 100 Rand voucher. Isn't that nice, Natasha?
It is very nice and also seems really easy.
Yes, and this voucher, remember, Mindset is for everyone that will register from today. So make sure that you get on your Samsung tablet or your premium smartphone. Then after that, you need to be careful. On this voucher, you need to use it once. So meaning if you buy a content that is worth 50 Rand, you'll be forfeiting another 50 Rand. So it's just that 100 Rand, and you need to use that 100 Rand. But now, this is how the hub looks like. You have a book off shelves, more like your own library or
virtual library.
A virtual library, I like that. And then you click on the store. When you click on the store, that's where you'll be seeing the books that Mindset has. When you click on store, you search for Mindset Learn. Then you'll be viewing the content that Mindset has for grade 10, 11, and 12. So it's for everyone, irrespective of what. And then Natasha, take us through. After viewing that material, you'll be selecting the one that you like, and then you can see what we have on that topic. We have summary or checklist. We have questions. We have video information and solution. Isn't that nice? Because Natasha, we've been having a lot of Mindsetters who always send us some questions, and at times we do not reach to all of them at the same time. So they can have a certain topic they like and the solutions.
Yes, an absolutely fantastic idea, especially for all of you out there who are so keen and send us all your questions all the time. Now you can get solutions for all those questions.
Exactly, but it doesn't end there. You need to pay now or get it on your own device. When you go to payment options, you have two options. One option is to use your free voucher, your 100 Rand free voucher, or secondly, you can use a credit card. And then there you go. You have it on your own shelf, on your virtual library, and you can use it at any time. You don't need internet connection thereafter. That's also brilliant, because at times we'll be complaining about data bundles when you need to go via internet. But now you have all the questions, the solutions right on your smart device.
Yeah, I think it's a really good idea, a good device if you know how to use it, a good method to learn extra and learn more.
Exactly, and a big thank you to Samsung Learning Hub for making sure that we have this content, and it's for you, Mindsetters. But now, for this show, all you need to do is to interact with us, ask us some questions live, and we'll take them through, because we are doing mathematics, and Natasha will be telling us the topic that we are doing.
All right, guys, today we're looking at probability, which some of you would probably have seen before. I'm sure by this stage in the year you have seen it before. Specifically, we're going to look at calculating basic probabilities, just a reminder of how to do that, and also touch on unions and intersections.
Nice one. And here's the link that you need for your notes that are for free. You need to go to learnextra.co.za/live. But secondly, if you can go through that, I have a fast link for those notes on Facebook. Our page is facebook.com/learnextra. Like the page, invite your friends also, and join our community, and let's get interacting. But lastly, follow us on Twitter @learnextra. Let's enjoy the show. Enough talking.
All right, guys, so some of the key concepts, you already, by this stage in the year, know what a probability is. You have uncertainty that affects you in everyday, in your everyday experiences. Every day in life, you make decisions, you make choices. When you choose to get up in the morning, you could have chosen to stay in bed. There's always two options, right? So uncertainty really presents itself to some degree in every event around us every day, all right? We use probability to describe these uncertain events, and what you guys need to remember as we go on, especially with your calculations, is that your probability values will always lie, it's always going to be a number between 0 and 1. And we'll discuss a little bit later on what the probability of 0 means and what a probability of 1 means. Okay, so some of the key terms that you would have seen when dealing with probability. An experiment, just a reminder, an experiment refers to some uncertain process, and we'll go through an example just now. An outcome of an experiment is a single result of that experiment. Your sample space is really just the set that will show you all the possible outcomes of whatever experiment you were busy with. Okay, so it's going to show you all of the possible outcomes. And we denote the sample space with the symbol S. All right. The size of the sample space, which means the total number of possible outcomes that you're looking at, we denote the size of your sample space with the symbol NS. Okay, so in other words, size of the sample space, or number of elements within the sample space. Okay. An event, now you would have heard this quite often as well, an event is a specific set of outcomes of an experiment that you are interested in. So an event we denote with the letter E, all right, and the number of outcomes in that event we denote with the symbol NE. Okay, so that will tell us the number of events, and E tells us the event itself. So what is an event? What is an experiment? What does it all mean? Obviously, it makes more sense when we look at it in terms of an example. All right. So an experiment, for example, would be taking a coin and tossing it in the air. So you take your coin, you toss it. It can either land on heads facing upwards or tails facing upwards. Now, a possible outcome, you see that word again, a possible outcome of tossing the coin is that it lands with your heads facing up. Okay, so that's an outcome of the experiment. Now, since a coin can only land in one of two ways, so we're going to ignore any possibility that it lands on its edge. That's a whole different thing, and we're not talking about that. So for us, a coin can only land in two ways. It can either be heads or tails. So therefore, our sample space S is the list of everything that can possibly happen. So in our list, we've got H for heads, T for tails. So the size of the sample space, we denote with NS. The number of elements within your sample space in this case will be 2. And so for example, if we say we want the coin to land with showing heads, all right? So the event that we are interested in will really just contain one outcome, and that outcome, your only favorable, you'll hear me say that quite a bit, your favorable outcome here is the coin landing on heads. So therefore, the event that you're interested in, the favorable event, is just going to be heads showing up on your coin, and therefore the number of events or the number of elements within your events is just going to be 1. All right, so that was just giving you an example of how we use all of these terminologies. What is an event? What is an experiment? What is an outcome? We, at this stage in the year, expect and assume that you already know that. So this was really just a quick revision, getting those concepts back to the forefront of your mind. All right. Okay, now calculating probabilities, you would have done this to some extent already. Remember, a probability, as I said before, is a real number between 0 and 1. It tells you how likely it is that an event will occur. All right, so we also state probabilities with percentages, as you're going to see later on. Now, what does a probability of 0 mean? Okay, so for example, if you think about something that will never ever happen, so God forbid the sun shines at night, we know it's not going to happen, right? So therefore the probability of that event occurring is going to be 0, impossible. Or an even better one is if you have, you know, your normal 6-sided dice with each of the faces numbered 1 to 6, the possibility of ever getting a 7 on a single roll, 0, because your die only goes up to 6. Okay. A probability of 1 means that an event will always occur. So for example, the sun will always rise. So the possibility of that happening, 100%. Okay. When all of the outcomes of an activity are equally likely to happen, so they're very random, they're equally likely to happen, there's no bias, then you can calculate the probability of some event that you are interested in by using this probability formula. So the probability of whatever event you're interested in, probability of some event, is equal to the number of favorable events divided by the number of possible events. I'm going to quickly look at the one we did in that example. Remember our event there, we were interested in getting a head facing upwards when we tossed a coin, right? So the event there was just made up of this one element, right? So the number of favorable ways to get that, there was just one way we could get that. The number of possible outcomes, so in other words, our sample space, there were 2 things that could happen. We could either get a heads or a tails. So therefore your sample space, total number of possible outcomes, was 2. There's 2 possible things that could happen when you toss that coin. It can either end up showing a head or it can show a tail. All right? So therefore, if we now had to work out the probability of getting a head on a coin toss, it's going to be the number of possible ways that could happen, which is simply 1 way, over the number of possible outcomes, which is 2. So therefore, the probability of getting a head is a half, or 0.5, or we can state it as percentage form as 50%. Okay, generally you'll notice when we do this, when we talk about probabilities, we're always going to refer to them either in decimal form like 0.5, or we can state it in percentage form, so like 50% as an example. I think that maybe it may be a good place to take a quick break before we go into our questions for the day.
I like that idea, and let's just go over the break, Mindsetters. But now, remember, Mindsetters, that you can still chat to us on Facebook. Our link is facebook.com/LearnExtra. We're waiting to hear from you, great hands. If you have any questions, as you're about to take these questions, be ready. Get everything, your material ready. We'll see you after this. Welcome back, Mindsetters. Now, before the break, we told you more about revision and getting you ready for revision. But also, I need to remind you that the exams are just around the corner. But don't worry, because we are here for you as Mindset. From the 14th of October, we'll be bringing you our exam score revision. How nice is that, Natasha?
Okay, I know that we do it every year, so I think it's a fantastic, fantastic idea for everyone to catch
And guess what? On it, we'll be promoting people, because I feel like we need to upgrade the Mindsetters and promote them. So all the grade 10 slot, they are moving up to 5 to 6. How nice is that? So grade 10 show will be from 5 until 6. You're not yet in grade 11, but we want you to experience what the grade 11s are experiencing. And then as for grade 11s, you're moving to the grade 12 slot, which is 6 to 7. That's also awesome, because I feel like we're no longer going to be calling you guys pre-matriculants. You are our matriculants.
Absolutely. So it's, I think it's a good idea to get everyone already ready and thinking ahead for next year. It's the first time that you've been called grade 11s. If you are watching, grade 11s have been called grade 12s.
Nice one. On that note, let's continue.
All right, so we're carrying on with questions on calculating probabilities. Before the break, I just reminded you about all of the key terminology that you needed to be able to answer the questions as we go on. All right, so this is our first question for the day, and it's talking about everyone's favorite subject, of course. So we've got a letter is chosen at random from the word mathematics. And they ask you, what is the probability that this letter is an M, a C, and then lastly a vowel? Okay, so the first thing we need to do is we need to set up a sample space in order to answer this question, all right? How do you set up your sample space? Well, you look at all the possible outcomes. So, you know, if you were to blindfold yourself and just sort of twirl a pen around and see what letter you ended up on, what are all the possible different letters you could end up on? Obviously, it's all of the letters in the word mathematics. So therefore, our sample space is going to be all of the letters from the word mathematics. Okay, so it's your M, A, T, H, E, M, and the A, T, I, C, and S. So you could possibly land on any one of those letters if you randomly sort of dropped your pen on a letter with your eyes closed. So therefore, the number of possible outcomes is going to be, you simply count the number of elements within your sample space. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the number of possible outcomes is 11. Now in part A, we are looking at the event of landing on the letter M. So our event here is that when you close your eyes and then stop your pen magically at one of the letters, you're going to end up on an M. Now remember, to work this out, we know the probability of getting an M is going to be your number of favorable outcomes. So in other words, the number of M's in your sample set all over the total possible outcomes. How many M's do we have in the word mathematics? Well, if you simply count them, we see we've got 1, 2. So therefore, the number of possible times you could end up on an M is going to be equal to 2. And the number of possible letters you could end up on is 11. So therefore, the probability of getting an M is 2 over 11. Or, as I said to you, we prefer to always write this in percentage form or as a decimal. So 2 divided by 11 as a decimal is 0.18. If you want to change that into a percentage, just times it by 100. And you're going to get 18.8%. So the probability of ending up on an M is 18.8%. All right, so similarly, if you look at part B, what is the probability that you end up on the letter C? Well, look at the word mathematics. How many C's are there? We see that the only letter C is, here we go, just before the last letter in that word. So therefore, there's only one possible time that you could end up on the letter C. So the probability of getting the event C is going to be 1 over your total sample space, which is 11. So it's your favorable outcome, which is 1, divided by the number of possible outcomes, which is 11. All right, again, you can either leave it in decimal form or as a percentage. I'm going to leave this one as a decimal, and it's 0.09. All right. Then the last part, which is quite interesting, assuming that all of you guys know what a vowel is. Remember, your vowel, if you're thinking of your letters and your alphabet, vowels, A, E, I, O, U. Okay, and all the other letters are called consonants. So if we're looking for the probability that the letter we land on is going to be a vowel, we look at the word mathematics and see how many vowels there are. So how many favorable outcomes there are. Okay, so let's count the number of vowels. We've got A, so that's 1. The next one's going to be E, so that's 2. Another A, that's 3. Remember, it's A, E, I, O, U, so there's an I. All right. So the event of getting a vowel, the probability of getting a vowel is going to be your number of favorable outcomes, which is 1, 2, 3, 4, or the number of times you could have success is 4 of your total sample space, which was the number of possible outcomes, which was 11. So 4 divided by 11 will give you, and if we change that into percentage, if we like, that's going to be 36.4%. 36.4%. All right. Now, guys, just on that question, the probability of landing on a vowel, we could have turned that around, and we will talk about complements and that a little bit more next week, in next week's lesson. But we could have said, what is the probability of ending up with a consonant? Okay. Now, we know that the probability of getting a vowel is 4 out of 11. So there were 4 vowels in the word mathematics. But that means then that the other 7 letters must all be non-vowels. They must all be consonants. So we could quite easily have said, what is the probability of ending up on a consonant? And without you having to calculate anything, it's literally going to be 1 minus the probability of getting a vowel. So 1 minus 4 over 11, which will give us 7 over 11. Okay, but as I said, we will deal a little bit more with complements and all of that kind of thing in next week's lesson when we delve into probability and the more difficult types of probability that you guys will encounter. Okay, so for now we're just looking at the basics, just reminding you, taking you nicely and slowly into the probability concept, right? Some of the other key things that we need to remember when dealing with probabilities: unions and intersection. What is a union? What is an intersection? Let's have a look. So the union of 2 sets is a new set that contains, very importantly, it's a new set that contains all of the elements that are in at least one of the 2 sets. Okay, it has to be all the elements that are in at least one of the 2 sets. The union, we write it as A union B, so that's just a little smaller u, A union B. The intersection of 2 sets is also a new set, but this is one that contains all of the elements that are in both sets. The intersection is written as A intersection B, so almost like an inverted U. All right, so what is an intersection? What is a union in terms of a diagram? All right, so I've got 3 different sample spaces that I've drawn for you, and let's see what we mean by looking at these diagrams. All right. Now, if you guys have a look, right, and we specifically now, let's just get a nice pen up so you guys can see it. We're specifically going to look at the middle column. You will see that, so we're highlighting this middle section. That's what we're concentrating on, right? Okay. If you have a look at that sample space, you can see that A intersection B is empty. So in other words, there are no elements that are common to both the sets A and B. Okay, so this middle sample space that we've got drawn here, your Venn diagram, this shows that there is no intersection between the 2 sets. All right? So that's obviously because the 2 sets do not overlap. Now, if you look at the final column, A union B, we see that that is equal to the entire set. So A union B here is the entire set of A, because if you notice, the set B is completely contained within set A. So therefore, your A combined with your B is going to be equal to the complete set A, since B is contained within A. All right. Your A intersection B, so that's this part here now. That's right in the middle. A intersection B is equal to the whole set B, and that's because B is completely contained within that intersection. Sorry, because B is completely contained within your set A. All right, so let's just get a pen back up so we can make some notes here. So A union B in the final one is equal to the whole set A. And then what was also special about that is that because B was completely contained within A, then the intersection A intersection B became this whole set B. It obviously will make more sense as we look at a few more examples, but it's concepts that you need to be aware of. All right. Now, we have a probability, well, we use this, we can call it a formula. I don't really like the word formula because it's not really a formula. Guys, I haven't really touched on the first little sample space, so I quickly want to do that before we go on to the next concept, is that if you look at your first sample space, A intersection B is obviously the little space where the two sets overlap. Okay, so that was your A intersection B. And then if you were looking for A union B, it's going to be all of the elements in A plus all of the elements of B. So this first column is generally what you guys would have seen a lot of, where just two Venn diagrams or two sets intersect each other. You get your normal intersection and your normal unions. The reason I pointed out the last two specifically and enlarged that for you guys to see is that it was a little bit different. Okay. All right. Now, often we are going to ask you to find the probability of this or that, the probability of A or B. All right. So if I wanted you to find the probability of A union B, the union is just another way to say or. Okay, so if I want you to find the probability of A union B, another way I'm going to say that is the probability of A happening or B happening. Then we use this formula, which is equal to the probability of A. You add that to the probability of B, but then you need to subtract out the intersection of the two sets, and it makes sense because obviously if you don't subtract out that intersection, you're going to be overcounting some of the elements. Okay, so the probability of A or B is equal to the probability of A plus the probability of B minus the probability of the intersection of A and B. All right. So when we use this, there obviously has to be an intersection between the two sets. What happens when there's no intersection? Well, that leads us on to the next concept, which is mutually exclusive events. So these things cannot happen at the same time. So for example, you cannot pass and fail maths in the same test. You either pass it or you fail it, right? So those concepts are mutually exclusive. So two events are called mutually exclusive if they cannot occur at the same time. It can't be night and day at the same time. Whenever an outcome of an experiment is in the first event, it cannot also be in the second event if the events are mutually exclusive. So if we go back to our diagram, have a look. This one here, this middle one, A and B, would be mutually exclusive because there's no intersection. You can either have A happening or B happening. There's no possibility of both happening at the same time. So therefore, that middle diagram would be a perfect example of mutually exclusive events. All right. So the intersection of mutually exclusive events is equal to 0. Then if you're trying to find the probability of A or B, it's going to just be equal to the probability of A plus the probability of B. So the union of the two sets is simply going to be the sum of the two individual probabilities. Okay, so that's when you're dealing with mutually exclusive events. So you obviously have to first decide whether your events are mutually exclusive or are they intersecting, and then later on, when we see you next week, we'll talk about independent and all of those other fancy things. All right. Abram, is it time for us to have a break?
Yes, and we'll take some questions after the break. Right, mindsetters, before we take that break, remember, if you're struggling and need some extra help, we have our help desk, of which it's now available now even on your Mixit. So make sure that you add Learn Extra, that app, on your Mixit and send some questions. That is also a simpler way of communicating with you. Otherwise, stay tuned. We'll see you after this. Welcome back, Mindsetters. Now, if you're joining us right now, you're a bit late, but you can still catch up because we love taking you along on our ride. But otherwise, we have some questions over Facebook. Make sure that also, if you have your cell phone next to you, you log on to our Facebook page, which is facebook.com/learnextra. Interact with other Mindsetters, help other Mindsetters, and also ask questions because we have a team of Mindsetters that is ever ready to help you through. Natasha, I have a question from Spewer Morgan Makatini. He says, when working out probability of an event occurring, will you be wrong if you leave your answer in fraction form?
No, you can. So if you answer, for example, in our last question, I think it was 4 out of 11 or something like that, you can leave it like that, absolutely acceptable, unless, of course, your teacher specifically said, write your probabilities as a percentage, then you would need to go that one step further. But there's nothing wrong with that.
All right, I see that the Mindsetters are on the page, and Noreen Machaka says, you guys are the best. I watch the show and record all the grade 12 revision shows. Tell you what, Mindsetters, let me remind you again about our time slot. The new time slot will be kicking in from the 14th of October, which is about next week. So grade 10s, your show will be at 5 until 6, and then grade 11s, your show will be from 6 up until 7. And for the awesome grade 12s, we'll be having an hour and a half from 3:30 up until 5 o'clock.
Fantastic.
That's it.
All right, guys, so let's carry on with our probability questions. Going on to question 2. Here we are told that cards numbered from 1 to 10 are placed in a bag and a card is drawn at random. Okay, so I've started putting up random little rectangular shapes. So they're numbered from 1 to 10. So we've got 1, 2, 3, 4, 5, 6, 7. So you can imagine, you know, probability is quite a nice practical thing. You can do all of your experiments at home and test these answers and see that it makes sense. Okay, so you've got all of these cards numbered from 1 to 10. Imagine yourself blindfolded. You reach into the bag and they say, give the sample space. Okay, for that you can't be blindfolded. For that we need to have our eyes open. So our sample space, remember, is the list of all the possible outcomes. So sample space is all of the possible things that we can get when we reach into that bag and draw out a numbered card. So we could get either a card numbered 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. Okay, so that's all the possibilities that you could get on your numbered cards. How many elements are there? Because obviously we will need that answer when we start answering questions. The number of possible outcomes is 10. Okay, let's have a look at part B. So now here you imagine yourself blindfolded. Well, again, not blindfolded, damn it. We can't be blindfolded just yet. Because now, again, we need to represent something. So we need to have our eyes wide open and look at what's being given to us and then answer the questions on this. All right. They say represents the event P of drawing a prime number. Now, remember, you've got these cards that are numbered from 1 to 10. You've got to firstly identify the prime numbers so that you can list this event P, which is your set of prime numbers. So let's start there by listing our set. So we've got P, which is the event of getting prime numbers. And let's go back to our cards and see which numbers are prime. Now remember, what is a prime number? A prime number has only 2 factors, 1 and itself. Okay, remember that? So therefore, identifying our prime cards here, we know that 2 is a prime number because only 2 divides into itself and 1 divides into 2. 3 is another prime number, so is 5, and so is 7. So let's have a look further down. No more prime numbers. So therefore, the number of prime numbers, look at your little cards with all the P's on them. We've got 1, 2, 3, 4. Right. So now we've got to list or represent this event. So we can't just write the number 4 because that's not going to make sense. We need to list all the elements that make up your set of prime numbers. The event getting a prime number, you could get a 2, you could get a 3, a 5, or a 7. Okay, so that is our event getting a prime number. All right, let's have a look at part C. List the event F of drawing a factor of 10. So F stands for factor. What are the factors of 10? Okay, so this is really just getting you into the idea and the concept of listing events. What is an event? What is an outcome? How do we represent them? Okay, so it is very important. You need to have all of these ideas so that you can answer the trickier probability questions. All right, so here we're looking for the factors of 10 that we can then list as the set F. What are the factors of 10? The numbers that divide into 10. So here I'm going to use a different color. Let's use the blue. All right. 1 is a factor of 10, right? 1 divides into 10. 2 is a factor of 10. 2 divides into 10. 3, no. 4, no. 5 is another factor of 10. And then lastly, 10 divides into itself. So therefore, 10 is a factor of itself. So we've got 1, 2, 3, 4 little blues in our rectangular card. So therefore, the set F is going to be made up of the numbers 1, 2, 5, and 10. So that's the list of all the events or all of the outcomes that will possibly be the factor of 10. All right. So if you pick up any of those cards, you are picking up a factor of 10. All right. Then they say, list the events P union F, which really means we want the list of either drawing a prime number or a factor of 10. Now guys, the reason this becomes important, as you can imagine, is if you were asked a question like, find the probability of drawing or finding or getting a prime number or a factor of 10. So it's the probability of a factor of 10 or a prime number. In order to answer that, you first need to have your event listed out nicely so you can just write it down. Okay, once you've got everything listed out, it's really easy. So we want the union P union F, which is drawing a prime number or a factor of 10. All right. So it's going to be all of the elements that occur between both the sets. Obviously, we're not going to repeat numbers. So P union F is going to be this part B plus part C. So we're going to have 1, 2, 3, 5, 7, and 10. And guys, you'll notice that I have subtracted out intuitively the intersection. You can see that 2 is repeated, but we don't repeat it in our listed sets. Okay, so P union F is going to be those two sets, all of the elements that are in those two sets is in your union, and obviously you subtract out the intersection because you don't want any overlapping numbers. All right, so that also falls into probabilities when we get to that part of it. And then lastly, they say represent P intersection F. So what is the intersection of prime numbers between 1 and 10, and then factors of 10 between 1 and 10? Okay, so what is P intersection F? And let's have a look at the common elements between P and F. We see that we have a common 2 and a common 5. So therefore, P intersection F P intersection F is going to be just those two elements, 2 and 5. All right. Now we could quite easily have then turned this into a probability question, and we could have said, what is the probability of getting a prime number that is also a factor of 10. Okay, so we could have combined that question and given it to you in a probability form. But what I want you to take out of this exercise is that if you list it, if you understand how to list your events, your favorable outcomes, whatever the question is asking you that you need to be trying to get. So, for example, you needed to be getting all the prime numbers between 1 and 10. Those are concepts that if you list your event correctly, when you later on do your probabilities, it all comes together and makes sense, like in the next question.
Right. Before you move to that question, Pele says, why that answer D we did not include 4, 6, and 8?
Answer D,
Yes.
of drawing a prime number or a factor of 10. 4 and 6 and 8 are not factors of 10, neither are they prime. So therefore, you can't include 4, 6, and 8 because the event P union F is specifically asking you to draw a prime number or a factor of 10. And since 4, 6, and 8 aren't prime and they aren't factors of 10, it's not going to fall in your set.
Right.
All right. All right. Okay. Let's carry on to the next question. All right, and this is where it all sorts of comes together. Everything we've done so far. We've learned how to list events and list sets and that, and we've also calculated basic probabilities. Now let's put it all together with this question 3. All right, so we say that a bag contains 6 red, 3 blue, 2 green, and 1 white ball. Okay, so that's 12 balls altogether. A ball is picked up at random here. So here is where you can blindfold yourself and you can pick out a ball at random. Determine the probability that the ball is red. Now guys, remember, in order to answer your probability questions, you need the sample space. You need to know what you're dealing with, all right? So what do we have? We've got 6 red, 3 blue, 2 green, and 1 white. So therefore, the total number of possible outcomes, the number of elements in our sample space, is 6 plus 3, which is 9. 9 plus 2 is 11. 11 plus 1 is 12. All right, so there's 12 possible outcomes from this draw. We are looking at the probability that we randomly pick up a ball and this ball is red. Okay. So we know that there's 6 red balls, 3 blue, 2 green, and 1 white. So therefore, if I now list my event, all right, so I'm going to say R is going to be possibility of getting a red ball. So R stands for your red ball. And then when I'm saying the probability of R, I'm obviously talking about the possibility of drawing a red ball from your bag of 12 balls. So remember, that's the number of possible or favorable, the number of favorable outcomes. So the number of red balls divided by the number of possible outcomes. So what are we saying? How many red balls are there? Divided by the number of total balls in the bag. So remember, we're dealing with 6 red balls in your bag. So therefore, the number of favorable outcomes is going to be 6. And then the number of possible outcomes is 12. All right, so therefore 6 out of 12 balls will give you success. If you draw out 6 red balls, then obviously you're happy. So therefore, that will give us 0.5 or 50%. So the probability of drawing a red ball, on the first draw, you put your hand in, you take out a red ball. There are 6 of them. There's 12 balls altogether, so it makes sense. The probability of drawing a red ball is going to be 50% because it's exactly half the number of balls in the bag. You're nodding your head. You understand, Abraham?
Yes.
All right. The next question, determine the probability that we draw out a blue or a white ball. Okay. Now this is where we've got to think of that concept that I introduced before. Remember the concept of having mutually exclusive events. Now, if a ball is white, it can't be blue at the same time. It's not possible. We're just dealing with individual colors. So therefore, the probability of getting a blue or a white ball, those are mutually exclusive. So in other words, there's no intersection, there's no midway, all right? There's nothing that sort of like a combination of the both. There's no blue-white ball, right? It's either going to be a blue ball or a white ball. So therefore, those are two mutually exclusive events. So therefore, set this up. This is part B. The probability of getting a B for blue union W for white is simply going to be the probability of getting a blue ball plus the probability of getting a white ball. These we already know how to do. It's simple probabilities using our formula, number of favorable outcomes over number of possible outcomes. So how many blue balls do we have? We've got 3 blue. We know that the number of possible outcomes is 12. So therefore, the probability of getting a blue ball is going to be 3 out of 12. Plus the probability of getting a white ball. We also know there's 12 balls altogether, but how many white balls are there? It's just 1. All right. So therefore, the probability of getting a blue or a white ball is simply the sum of the two probabilities. So it's 3 over 12 plus 1 over 12, 4 over 12, which is a third, or 0.3%, 0.3 recurring, or 30%. All right, 33.3%. Okay, so this is important, this concept of why could I just add the two probabilities together? Very important, guys, because there's no intersection between the two events. Okay, you can only add the probability of one event plus the probability of another to get the probability of the union if there's no intersection. Okay, so the probability of B union W, we can simply add them together. The only reason we can do that is because there's no intersection. Those events are mutually exclusive, and I'm overstating it because it's a very, very important concept. Okay. Right, let's have a look at part C. What is the probability that the ball is not green? Now, there's more than one way to do this. I'm going to do it my way. If you've got another way and you get to the same answer, then let us know on the Facebook page, but there is more than one way to do it. Okay, so how many green balls do we have altogether? We've got 2, right? They say determine the probability that the ball is not green. So remember I was saying to you, probability is a very practical section. So you can think of it logically, right? If there are 2 green balls in this bag, and there are 12 balls altogether, then obviously 10 of those 12 are not green. All right, let's go through it again. We've got 12 balls altogether. We know that 2 of those balls are green. Okay, so the number of green balls is 2. So if 2 of them are green, then obviously the remainder is not green. And we could work it out that way. All right, so therefore, without going into complements and all of that, we can determine the probability of getting a not green ball. Okay, so this is part C. So the probability of not green is going to be all the non-green balls, so there were 10 of them, divided by all your possible outcomes, which was 12. All right, and 10 divided by 12, if we do this as a percentage form, we're going to get 10 divided by 12. See, let's just do that again. 10 divided by 12. 0.83 as a percentage is going to be 83.3%. As you can see, the percentage is quite high, which makes sense because there are quite a lot of balls in this bag that aren't green. Okay, so that's why the percentage is that high. And then lastly, what is the probability of getting a ball that is not green or red? So now we're excluding all of the green balls and all of the red balls. So probability of not getting any green balls or getting any red balls. We know that The probability of not green, we just worked it out just now, was 10 out of 12. And if we look at red, right, how many red balls are there? There's 6. Okay, so if I'm not wanting any green balls or any red balls, because those are mutually exclusive, again, you've got to add the two probabilities together. And once again, we have run out of time, as we do every week. Thank you so much for joining us.
Thank you so much, Mindsetters. Look out for our Learn Extra exam school competition that will be running this month, proudly sponsored by Samsung. Otherwise, peace.